So as we know, list not only contains heterogeneous elements, a list can also contain another list. So if at all you come across with a situation where one list is containing another list, then that is what we call as nested list. And most frequently we consider that as a matrix, because nested list is nothing but list within a list, which is ultimately we can name it as a matrix. Now let's see, for example, here I'm taking some n where this is a list. So this is the beginning, this is the ending of this square brackets. Now how many elements do we have here? This is one element. This is one element, individual numeric values. But here the third element is a list itself. So these two are independent natural numbers here. Okay, but here the third element, in place of third element, you could see here, we have taken a list again. So this is nothing but your nested list. Now, whenever I will print this, so I'll be getting, so when I'm printing this, I'll be getting this as 10, 20 and this third item as a list itself. Now, when I'm writing, say, because this 10, so we have 10, the second item is 20, and then we have a list here. Inside this list, there are two items. One is your 30 and the second one is your 40. So when I start putting the indices for these elements, so this index is 0, this index is 1, and this inside this list, this is your index 0, this is index 1. But this element altogether is identified by index 2 because is a continuation. This is 0, this is 1, this is 2. So in order to access this 30, I cannot use only one index, rather I have to take the row index, I mean this index, that is 2, because that is where this list is positioned, and then its internal index. So 30 can be accessed by using two indices, that is 2 and your 0. Similarly, when I am accessing 40, I should be writing index 2 and followed by the index 1. So that is what we have done here. So n of 0 means I am referring to 10. N of 2. N of 2 means this entire list I am going to get. See, n of 2 is not going to give me only 30 or 40 because n of 2 is the third element. So third element itself is a list. So hence we are going to get the third element, that is nothing but what? 30 and 40. Now when I am writing two indices, n of 2, 0. So 2, 0 indicates what? 30. And similarly n of 2, 1 is going to indicate 40. So this is the way how actually we store the matrices. So we could access these elements just like the way we access the array elements in a multi-dimensional concept, right? So using row index and column index here. So now let us see, if at all I want a particular nested list to be printed in the form of a matrix. So how can we do that? So let's say we have taken a matrix here, in fact a nested list, because you can see this is one item which is a list itself, this is another item, list itself, and this is another item. So we have three lists available inside a list. So this is a nested list, right? So first list index we can find at 0, second one is your 1, and the third one is your 2. Now each of this index actually represent one list here. Now in order to access each of the element, I mean for example 10, how can I access it? I can write 0, 0. I mean row index 0, column index 0. Similarly 20 can be used like 0 and 1. Similarly 30 can be 0 and 2. When it comes to 40, 50, 60, you can say 1, 0, 1, 1 and 1, 2. Similarly the last one 2, 0, 2, 1 and 2, 2. Right. So now when I want these elements to be in matrix style, so I have to take the help of nested loops here. So what we have done here, we took a outer loop here where you can see I starts with range of len of n. So we have already know that how to calculate length of the list. So when I say len of n, so len of n is nothing but how many elements do we have? 3 elements. So this is going to produce what? 3. So when range of 3 is calculated, means what are the values does it produce? 0, 1 and 2. Now we have the inner loop which is going to be dealt with j, and now we are writing range of len of n of I. So you can see when this outer loop executes for the first time, what is the value of I? It is 0. Now when the inner loop executes, len of n of 0, n of 0 means nothing but I am referring to this entire list. Okay, so n of 0 is the first list where how many elements are available? 3 elements. So this is going to be 3. So now when I'm printing n of ij, what is I value? It is fixed 0. Okay, and this range of 3 means once again it is going to produce 0, 1 and 2. So when I'm writing n of ij, that is I'm going to get what? 0, 0. What is 0, 0 is 10. Now next time j value becomes 1. So 0, 1 means what? Your 20. Similarly, n of ij, that is 0 and 2 means that is 30. So by the end of this inner loop, what I could do is I could print the elements of first list. That is nothing but I can consider as my first row. Now immediately after the row is printed, I mean elements of row are printed, what we are doing here, because we want a matrix look. So for that what we have done, we have brought the cursor to the new line. So already we have got the first row holding the elements 10, 20 and 30. Now my cursor is somewhere in the next line. So now when we go back to the outer loop, so I now updated to what? 1. Now when I check this j loop, j len of n of I, n of I means what? N of 1, n of 1 means the second list, whose length is once again 3. So once again j is going to produce what? 0, 1, 2. So now this combination of ij is like 1, 0, 1, 1, 1, 2. What is 1, 0, 1, 1, 1, 2? They are nothing but your 40, 50 and 60. Right. So once again, after printing this second row elements, once again this print function will bring the cursor to the new line. And for the last time, where the I value becomes is 2, now length of n of 2, n of 2 is also holding what? 3 elements. So hence it is again 0, 1, 2. So this time this n of ij will be like what? 2, 0, 2, 1, 2, 2, which is nothing but 2, 0 is your 70, 2, 1 is your 80 and 2, 1, 2, 2 is your 90. So now after this what will happen? This entire loop is going to terminate. So in the meantime, we have got our elements in the matrix style where the first row is 10, 20, 30, second row is 40, 50, 60 and this one is 70, 80, 90. So you can change it. It's not like every row has to have same number of elements. You can change it. Suppose here I do not want 60, I can take only 2 elements. Here I want to add some 2 more elements, here 5 elements. You can do it because the inner loop is going to find out how many elements are there inside. Accordingly it is going to give you. Okay, let's say the first list is holding 3 elements, second one 2 and the last one is 5. So my first row will have 3 elements, second row will have 2 elements and the third row will have 5 elements. So you have the flexibility of taking as many elements into each of the list here. It is not mandatory that every list inside this nested list has to have. So list comprehension is one of the easiest and compact way of creating a list from any iterable object, maybe list, maybe tuple, dictionary, range. Mostly we make use of a range or maybe any of these uh, iterable objects based on some condition. Now let's see the syntax here. Here we are creating this list and within the square brackets we are mentioning some expression for some item that could be a variable in either of this, maybe list, tuple, range. And this if condition is an optional one. If you want to add you can, otherwise you can skip it. Now how does it work? Now, each item in this particular range or list, whatever we have specified here, on that, this condition will be applied if at all it is given, and then this expression will be evaluated on those items. And whatever this results, that will be added to the list one after another. Now, let's understand this with an example. Here we have taken x into x, that is nothing but my expression here, right? And for x, item is nothing but x here. In, we have taken range 1, 11. There is no condition attached here. So we know that this range function is going to produce the values 1 to 10. It's going to produce 1 to 10. Now, this x is going to take up each of the values, that is x is going to be 1 for the first time. As a result, x into x is going to produce 1, which is added to the list. Next time x becomes 2. So as a result, this expression will be 2 into 2, 4, which will be added to the list. Third time x becomes 3, and as a result 3 into 3 makes it 9, added to the list. Likewise, for 4, 5, 6, 7, 8, 9 and till 10, each of the values have been multiplied with itself and it is being stored into the list. So S now holding these set of items starting from 1 to 100. Now, taking the second list here, you are preparing one more list here, where we have taken expression is simply x for x in S. What is S? Just now we have prepared this. This is the S actually. So this list I am taking as an input, and here I am adding a condition. What is the condition is? If x percentile 2 is equal to 0. So inside this S, whatever items which are divisible by 2 are to be assigned to this x, which in turn will be added to the list. Which means when I start from this 1, it is not divisible by 2, hence it will not be added. But when it comes to 4, 4 is divisible by 2, hence x is attached to this x. As a result, 4 is added to the list. Similarly, 16 is divisible, it is added. 36 is divisible by 2, it is added. Similarly, 64 and 100. So here, this S is nothing but what? It is a list, because we have said here can take list or tuple or a range. So here I am taking a list, and this is the condition we have attached. So we could prepare S initially without any condition. Now M is being prepared with certain condition. Now let's see one more example. Let's say we have taken 2 to the power x in the range of 1, 6. So it is going to produce what? 1, 2, 3, 4, 5. Okay. So for 1 it is going to be 2 to the power 1, that is 2. For x it is 2, then 2 to the power 2 is 4. When x is 3, it is 2 cube, that is 8. X is 4, it is 2 to the power 4, 16. Similarly, for the last time when x is 5, 2 to the power 32 will be produced. So this is one of the easiest way. I mean, list comprehension is the one of the easiest and easy way and compact way for creating list objects.